Hey, welcome back everyone. So in this video, we're going to learn how to calculate the mean and standard deviation of a sampling distribution of a proportion. We're also going to work through some practice problems for calculating the probability of events using a sample proportion. So if you're ready, let's get started. So a common measurement that we often use in business is proportions. So a population proportion is the fraction of values in a population that has a specific attribute. We calculate the proportion by taking the number of items in the population having the attribute of interest, which is denoted by a big X, and then we divide by the population size, or big N. We will use the symbol little p to denote the population proportion. We can also calculate the proportion in a sample. This is the same concept as the population, but now it's the fraction of items in a sample that have the attribute of interest. This is denoted by little x and represents the number of items in the sample with the attribute of interest. So then we divide by the sample size, or little n, and we're going to use the symbol p bar to denote a sample proportion. So in this video, we'll be using the symbol little p and p bar throughout. And you'll want to watch out if we're talking about a population or a sample. However, conceptually, the math here is the same. So here are some examples of proportions. So say we wanted to know the proportion of customers who use a 20% coupon at Bed Bath & Beyond. So in this example, the attribute of interest is whether the customer used a 20% coupon. So in the second example, this is a proportion of Americans who own a home. So again, our attribute of interest is home ownership. Now in the third example, we have the proportion of MiraCosta students who eat at the cafeteria on campus. So the attribute of interest here is eating at the campus cafeteria. And then finally, the fourth example is the proportion of defective phones. So in each of these, we can find the proportion of our attribute of interest by taking the number who have the attribute of interest divided by a population size or sample size, depending on if we're working with populations or samples. So like how we learned about the sampling error for the mean, here is the sampling error for a proportion. So the first two steps is to calculate the sampling error for a proportion, is to calculate the population proportion, and then the sample proportion. Then in step 3, the calculation is also the same as before. We will take the sample proportion and subtract the population proportion. So some things to note when we're working with the sampling distribution of p bar is the best estimate of the population proportion p will be the sample proportion, or p bar. Then any inference we make about how close our estimate is to the true population value will be based on the distribution of the sample proportion, or p bar. So now recall, when we learned about distributions, the binomial distribution is when we have two possible outcomes. So you can see a proportion is just another way of representing this, because you either have the attribute of interest or you don't. And we are just representing this as a proportion. We're going to use the following two formulas to determine if our sample size is sufficiently large. So first, we take the sample size of n and we multiply it by the sample proportion to identify the number of items that have the attribute of interest. We'll also use the complement rule to identify the number of items that don't have the attribute of interest. If both of these are greater than or equal to 5, then we could rely on the normal distribution as an approximation to the discrete binomial distribution. So here are the two formulas for the mean and standard error for the sampling distribution of our sample proportion. So the mean for the sampling distribution is simply just our p for the population proportion. You will typically be given this in any problem you see in the textbook or on any exam. Now the standard error is this formula, where we're going to take the square root of our population proportion multiplied by 1 minus our population proportion divided by the sample size. Now earlier in the chapter, we learned several theorems that allowed us to apply the sampling distribution of the mean, or x bar. Similarly, Theorem 5 takes all of the pieces that we just discussed and it allows us to work with the sampling distribution of p bar. So regardless of the value of the population proportion p, aside from p being 0 or 1, the sampling distribution for our sample proportion will be approximately normally distributed with our mean and our standard error if our sample sizes are sufficiently large. Note that the approximation to the normal distribution improves as the sample size increases and p approaches 0.5. So just like when we worked in the sampling distribution of the mean, we can also convert our sample proportion to z-values. So here is the formula to convert our p-bar into a z. You'll take the sample proportion, or p-bar, minus the population proportion, and then divide it by the standard error. Now here is the formula for the standard error. We take the population proportion multiplied by 1 minus the population proportion divided by the sample size, and then we square root the entire thing. So when we're calculating z-values, we will always want to calculate the sampling error and the standard error separately to make sure we're doing our order of operations correctly. So let's look at an example problem. So a big problem for taxpayers has been the recent increase in fraudulent tax returns being filed with the IRS in the name of taxpayers. Suppose the IRS believes that 15% of all taxpayers will be affected in 2016. Assuming the true proportion of taxpayers who get hacked is 0.15, what is the probability that more than 40 in a random sample of 200 will have been hacked? So in this case, our attribute of interest is people who get hacked on their tax returns. So the population proportion was provided to us twice in the story. Here, when it referenced 15% of all taxpayers, and then 0.15 for the true proportion of taxpayers who get hacked. So we have our p at 0.15, which is our population proportion. We also need to calculate our sample proportion. So here's our formula for that again. At the end of the story, it tells us the probability that more than 40 in a random sample of 200 will have been hacked. So if 40 is our x, or the attribute of interest, and 200 is our sample, we divide 40 by 200 and we get 0.20 for p-bar, or the sample proportion. So we now want to write our event of interest. We are essentially saying that we want to know the probability that p-bar will be greater than 0.20. We are not writing our event of interest in the terms of the number of people, or 40, but the proportion of people in the sample. So thanks to Theorem 5, we can use the standard normal distribution to calculate the probability that the sample proportion is greater than 0.20. The first step to use the standard normal distribution is to convert our sample proportion to a z-value. So here's our formula. So I'm going to just plug in our values. So in the numerator, we're going to calculate the sampling error. I will plug in 0.20 for the sample proportion, and it was given in the story that our population proportion is 0.15. So 0.20 minus 0.15 gives us a sampling error of 0.05. So now in the denominator, we'll take the population proportion of 0.15 and multiply by the complement, or 0.185, then divide by the sample size of 200. Then I'm going to square root the whole thing, and we get a standard error of 0.025249. Finally, I'll divide 0.05 by 0.025249, and we get a z-value of 1.98. You can see, to avoid any of the order of operations issues, I calculated the sampling error in the numerator first, and then the standard error in the denominator separately. So here is a graphic of the normal distribution curve, and we have denoted the z-value here that we just calculated. So we started with our event of interest as the probability that the sample proportion is greater than 0.20. So now we can restate that as the probability that the z-value is greater than 1.98. We are looking for the probability of the region highlighted in yellow. So as we've done before with other distributions, we're going to use Excel to find our desired probability. So the question you should always ask yourself, is the event of interest greater than or less than the number, or in this case, the z-value? So this is a greater than situation since we're looking for the probability of the yellow region to the right. Since Excel always calculates from left to right, we will use the complement rule here and take 1 minus then norm.s.dis, and then the inputs will be our z-value of 1.98 and true for cumulative, and we get 0.0239. So there's only a 2.39% chance that the number of fraudulent tax returns in the sample of 200 returns is greater than 20%. So we're now going to work through problem 7.57 that says 10% of US engineers are women. Suppose a random sample of 50 engineers is selected. So in part A, how likely is it that the sample of 50 engineers will contain 8 or more women in these positions? So step 1 is to calculate the population proportion. Well, that was given to us right in the story as 10% or 0.10. So step 2 is we need to calculate the sample proportion. So here's our formula for P bar, where we take X, or the number for our variable of interest given in the story, divided by the sample size. So we are interested in knowing how likely that our sample of 50 engineers will contain 8 or more women. So 8 is our X, and we divide by the sample size of 50, and we get 0.16. We can now write the event of interest as P of the sample proportion is greater than or equal to 0.16. Now, step 5 is to convert the sample proportion to a z-value, just like we did in the prior example. So let's start with the sampling error in the numerator. So I'll plug in 0.16 for the sample proportion, or P bar, and 0.10 for the population proportion, or P, and we get 0.06 for the sampling error for the proportion. Next, let's calculate the standard error in the denominator. So I'm going to plug in 0.10 for little p and 50 for n, or the sample size. I will plug that into my calculator, and we get 0.04242 for the standard error for the proportion. So now all we need to do is take 0.06 and divide by 0.04242, and we get 1.41 for the z-value for this sample proportion. So the last step is to use Excel to find the desired probability. So in this problem, we're looking for the probability that the sample proportion will be greater than, so we know that we'll have to use the complement rule here again. So in Excel, I'm going to take 1 minus norm.s.dist, and then input 1.41 for the z-value, and true for cumulative, and we get 0.0793. So there's nearly an 8% chance that the sample will contain 8 or more women. Now in part B, how likely is it that the sample of 200 engineers will contain fewer than 5 women? In this problem, the population proportion of 0.10 and the sample size has not changed, but now we're interested in fewer than 5 women. In step 2, we will calculate the sample proportion again. So we will take the 5, since we're now interested in fewer than 5 women, and divide by 200, and we get 0.025. We can now define the event of interest as P of the sample proportion is less than or equal to 0.025. All right, let's wrap this up now. Now in step 5, we now need to convert this sample proportion to a z-value. Like before, let's start with the sampling error in the numerator. We will take our sample proportion, or P bar, of 0.025 and subtract the sample proportion of 0.10, and we get a negative 0.075. Let's now calculate the standard error in the denominator. I will plug in 0.10 for the population proportion and 200 for the sample size. I'm going to plug that in a calculator, and we get 0.0212 for the standard error for the proportion. Now again, all we need to do is take negative 0.075 and divide by 0.0212, and we get a z-value of negative 3.54. So the last step is to use Excel to find the desired probability. Since we're now dealing with a less than, we will just use the output from Excel directly. So I will input the equals norm.s.dist and then enter negative 3.54 for my z-value and true for cumulative, and we get 0.0002. So there's nearly a 0% chance that the sample will contain fewer than 5 women. Well, everyone, that wraps up this video on the sampling distribution of a proportion. That also wraps up Chapter 7.